The COVID-19 pandemic exposed a critical global vulnerability, overwhelming dependence on synthetic pharmaceuticals with limited accessible alternatives for much of the world's population. Yet research published in scientific reports in 2021 demonstrated that the ethanol extract of Artemisia annua Wormwood, showed inhibitory activity against SARS-CoV-2 replication across all 7 tested varieties from 4 continents. This raised the question: could this widely available medicinal plant growing across the foothills of Kazakhstan be developed into standardized, stable, and accessible pharmaceutical products? My name is Adilya Moldashi, and that is exactly what this project set out to do. Artemisia annua belongs to the Asteraceae family and is one of 81 wormwood species found in Kazakhstan. It has been documented for its anti-inflammatory, antipyretic, antifungal, antiparasitic, and cytotoxic properties. Crucially, scientists found that the antiviral effect against SARS-CoV-2 was not attributed to artemisinin alone, but likely to synergistic action among multiple phytochemicals, and that this activity remained stable even after long-term dry storage at room temperature. Despite this therapeutic potential, tinctures, the most common extract form, are inconvenient. They require precise dosing, dilution, and special storage conditions. This created the research gap I aim to address. My central hypothesis was a stable, pharmacopoeically compliant caramel medicinal form can be developed using Artemisia annua extract combined with isomalt, preserving bioactive compounds while meeting standardized quality parameters. To test this, I set out to identify and characterize the raw material, isolate and analyze its active compounds, develop a reproducible caramel formulation, and standardize the finished product against international pharmacopoeia standards. Raw material was harvested during peak flowering at the foothills of the Ile Alatau Amati region before 10 a.m. daily to preserve volatile compounds. Stems were cut at 10 to 15 centimeters, dried at 30 plus or minus 5 degrees Celsius, and verified against State Pharmacopoeia of Kazakhstan standards. Key analytical tests included atomic absorption spectrometry for heavy metals, steam distillation for essential oil yield, and GCMS chromatography to identify the extract's full chemical composition. Extraction was performed by maceration in 70% ethyl alcohol, followed by a 24-hour settling period at no more than 25 degrees Celsius. For the caramel base, I selected isomalt, food additive E953, due to its melting point of 145 degrees Celsius, low crystallization tendency, and diabetic-friendly glycemic profile. The optimal ratio established after experimentation was 1:2, extract to isomalt. The mixture was heated to 140 degrees Celsius, cooled to 90 degrees Celsius, poured into silicone molds, and allowed to solidify at room temperature. Raw material analysis confirmed the moisture loss on drying of 6.5%, an extraction substance content of 40.2%, and an essential oil yield of 0.4%. Importantly, no heavy metals were detected in any analyzed sample. GCMS analysis identified more than 50 active compounds in the extract. The predominant constitutions were 1,8-cineol at 8.6%, alongside terpinol, alpha-pinene, and chemazoline. Notably, squalene was also detected, a triterpene with documented antimicrobial, antifungal, and immunostimulatory properties, further supporting the potential of this extract. The finished caramels was standardized into 5 parameters. Appearance: round, 1 cm diameter, dark caramel color. Average mass: 1.7084 grams, with all 20 units falling within 5% deviation limit. Disintegration: all tablets dissolved within 10 minutes. Water content by Carl Fisher titration below 2%. And organoleptic properties: pleasant taste, consistent texture, and color. All parameters met the requirement of the State Pharmacopoeia of Kazakhstan. This project successfully demonstrated that a stable, standardized therapeutic caramel can be developed from Artemisia annua extract, one that is convenient, accessible, and suitable for patients who cannot swallow conventional tablets, including children and elderly patients. Given the plant's documented activity against SARS-CoV-2 and the detection of over 50 bioactive compounds, including squalene, this dosage form represents a promising direction for future antiviral and antimicrobial pharmaceutical research. Thank you!